So projectile motion. Then, if I just can I reset that? Oh, okay. We're going to give it start off with it 0 heights above the ground because it simplifies the situation, and we're going to what we want to do is give it initial speed at an angle of 30 meters per second, and we press fire. It does something like that. Now, what we want to know is what is its range. So in this case, we can see its range was. It looks like about 19. I'm probably not getting quite right, but it looks like about 19.72. So let's just make a note of that. And so the range was equal to 19.72 meters. The other thing we'd like to know is how high did it go? What was its maximum height? So we can see they've identified that on this green bit here. If I take this bit here, I can actually go for any part of this journey, and it'll tell me after 0.9 seconds the range was this. And so the maximum height looks to be 2.87. I don't think it ever went any higher than that. Yeah, 2.87. So we'll say that the height it reached was 2.87. 87 meters. And what about the time of flight? So if we go down to around about here, 1.5 seconds. That looks like so actually 19.49. I might change that then. Like I say, I'm going to get this slightly off. Go on, sorry. How do you mean? So yeah, I mean, these numbers are not going to be entirely precise, but what we're going to do in a moment is see if we can calculate it for ourselves. So we're going to actually find out these values. We've measured them directly, but what we want to know is it possible to have worked this out beforehand if we just know the starting situations? In other words, if we knew that we were launching at 15 meters per second, and we knew that the initial speed was, and we knew that the angle was 30 degrees, then is it possible to work out the range, the height, and the time? Well, yes, it is. Of course, that's you can work out that by my tone. But how would we do that? So the first trick to doing that is you take the initial velocity, the vector of the initial velocity, and you break it down into its components, its horizontal and vertical components. So that's its actual velocity, and then if it's got essentially a vertical component of that, which you can call, I do it like that, so as I know that up, I'm saying that up is positive, and then I do one like that. Now, I'm going to jump ahead a little bit because we reviewed trigonometry recently. So this one's opposite. So u vertical is going to be u sine 30. And this is going to be u cos 30. Now, for now, we're just going to take that as read. But if you did a bit of trigonometry, you would see that would be the case. In other words, the horizontal component of u would be u cos 30. The vertical component of u would be u sine 30. Okay, let me just check the time. Okay. So in other words, if I was hovering above this experiment and I watched this cannonball fly over here and land on the ground, then I won't be able to see the height that it's gaining. I will only see, as far as I can see, something moving horizontally along the ground, maybe, or horizontally in the air anyway. I won't realize that it's actually producing a parabola. And likewise, if I was standing just here and it was along my line of sight, I may only see the thing going up and then coming back down again. So I would only see the vertical component, the vertical side of things. So that's